Hello and welcome to today's video, 242 valid anagram. So you're given two strings s and t, and you want to return true if t is an anagram of s and false otherwise. And an anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all of the original letters exactly once. So we have these two examples here. In this case, it is an anagram because you can arrange the s string here in order to equal t using all letters exactly once. And for this one, you can't do that because the, because like there's letters in here which don't happen in the t string over here. So that's why we return false. So yeah, it contains lowercase English letters over here, and we have some length constraints over here as well. Okay, so taking a look at this, we have to figure out some way in order to grab the count of both of the strings, the count of each character of both of the strings, and determine some way to compare between the two. Right off the bat, we can notice from these two examples that the lengths of the strings have to be exactly the same. Yeah, if we take a look at the constraints, it doesn't say anywhere that they're exactly the same string, so we can go ahead and check for that first. So we'll go ahead and do if length s, if not length of s equal length of t, then we can go ahead and assume it's false. Next thing we got to do is, so an idea would be to have two hash maps, one for s and one for t, and then we can iterate through the length of either one. It doesn't matter because they're both the same length because of this guarantee. As we loop through them, what we can do is we can count, we can add the character at the current index that we're on, and then add that to the hash map. So if we have let's say we have these two hash maps over here for rat and car, we have at index 0, we start off there, so we add r to the first hash map, we'll have r equals 1, and then for the second one, we're going to have c equals 1, right, as we get to the count. Now we move to the second one, we add the a to equal 1 as well, and we add the a to equal 1 on the other one as well. And finally, we hit t for the last one, and then we add 1 to that, and we have r for the last one, so we add 1 to that as well. So this, the key is the character, and the value is the count of that specific character for that string. Now, once we have these two hash maps generated, what we can do is compare them directly in order to determine whether or not they're the same. So yeah, we'll go ahead and check to see if they're both the same. If they are, then we're going to return true. So we'll go ahead and do that now. We'll generate those two hash maps. So we'll have hmap s, hmap t. We'll generate them like this. And then for everything in range length of string, we're going to go ahead and add to those hash maps. So hash map at s, what we're going to want to do is grab the character at that given index. So we'll go s at the index I, and then we're going to do equals hmap s.get si to initialize it to 0, and then add 1 for that. Same thing for the second hash map. We'll do this time t at I, and then we're going to get hmap t.get ti, initializing with 0, and then incrementing 1 if we see it. This will go ahead and generate the hash maps like we were talking about before. And after this, what we can do is we can return whether or not hmap s is equal to hmap t at the very end over here. So yeah, just to run this through again, we're going to go ahead and basically convert these, check to see whether or not they're the same length. If they aren't, then we return false. Otherwise, we just keep going. We initialize two hash maps and count basically how many there are. Using this over here, we'll go ahead and add that. At the very end, we return whether or not those two hash maps are equal, because if they are anagrams, then the counts and the basically the number, the characters that are in the string should be exactly the same. So if we go ahead and run this now, let's see. Built-in function or method object is not subscriptable. Right. Oh, missed my brackets over here. go ahead and run this again. Great, accepted. Now, the time complexity of this is O of n. Well, yeah, m plus n, where m is the length of the number of characters in the first string and n is the number of characters in the second string. And the space of complexity is also O of m plus n, where they both represent the same thing, because you're storing all of those values in the hash map. So yeah, thank you for watching.